So here we have functions f of x and g of x. Again, we're going to find our explicit equation. So if you've just been following along but not paying attention to words, this is going to be an important one, explicit equation, because that means you want to write it in terms of x only. And so that's sometimes another way that this question could be asked, is it could say, write g of f of x in terms of x only. What that means is we want to take our function and change it from our function notation, which here it is in the left, and write it in terms of x only. Start from the inside, and we have g of the square root of x. And then, working further, what happens with g of x? The function g of x says, whatever I plug into g of x, that value gets squared, and then I subtract 4. So we would have this squared subtract 4. Well, what happens with squaring a square root? Just becomes x. So we get x minus 4. Well, we're gonna talk about that, right? So that's our final equation, because when you square a square root, you just get x. And we have x minus 4, which is a line. So now if we only looked at our final equation, what would we say our domain was? Well, it's a line. We'd say it was everything. But we have to look throughout our whole equation and say, did we ever divide by anything? No. So we're never going to have to worry about dividing by 0. Did we ever have a square root? Yes. So in this one, we had a square root right at the beginning of our work. And what can't we take the square root of? We can't take the square root of a negative. So our domain is x has to be bigger than or equal to 0. Even though our final function, anything works once it's simplified. But according to the way that this equation was written, the equation was written this way, saying first we do f of x, and then we do g of x. And by doing f of x first, we ran into a problem. Because if you would plug a negative into f of x, you'd be taking the square root of a negative, and that wouldn't work. So our domain for this one is just bigger than or equal to 0. Okay? So should we write a little note now that we've done 2 of these examples? So our little note here, to find our domain, you're going to check your final equation, look at that, then look throughout your work for dividing by 0 and square roots. So in our example that we did before, our final equation showed us that we couldn't divide by 2, because that would make us put 2 in for x, sorry, because it would make us divide by 0. But earlier we divided by x minus 1, so that x couldn't equal 1. In this equation, our final answer is fine. It works for everything. But when we look earlier, we had a square root earlier, and we can't take the square root of a negative. So that affected our domain to be just bigger than or equal to 0. For part B, now we want to do f of g of x. G of x is x squared minus 4. And the function f says whatever you plug into f, take the square root of that. So now we are plugging in x squared minus 4 into f. And so we take the square root of it. So now to figure out our domain for our final function, well, we know that we can't take the square root of the negative. So to find the domain, we need to solve when is x squared minus 4 bigger than or equal to 0. And this is exactly where we started the lesson. Well, we know that it's equal to 0 because we can factor it. At x equals negative 2 and x equals 2. And if you made your number line, you could find out where is this true, where is this false. And you might be able to see, oh, if I choose a number bigger than 2, if I choose 3 or 4 or 5, that squared minus 4 will definitely be bigger than 0. This section will be true. If I try a number in between negative 2 and 2, like 0, then it will be negative 4. Negative 4 is not greater than 0. Then you would be taking the square root of a negative, and that would be false. And finally, large negative numbers, if you plugged in negative 5 squared becomes positive 25. Subtract 4 will still be greater than 0. This section is true. That's using our test values. At the beginning of the lesson, I also said, if you think about this as your x-axis and having a y-axis, x squared minus 4 would have two x-intercepts at minus 2 and 2. It's a parabola. Which way does that parabola open? Up. So if you draw a parabola through those points opening up, you can see that your y values are bigger than 0 here. And that's true. That they're false because they're negative here and they're true again here. So now the question is, how do we write that domain when we have two places that it's true? If you write it in set notation, this first true on the left is when x is less than or equal to negative 2. And the true on the right is when x is bigger than or equal to 2. And when we have two sections and we use this notation, we use the word or in between. It is here or here. We don't use the word and because in mathematics and logic, the word and means it has to be in both places at the same time. And it's very hard to be less than negative 2 and bigger than 2 at the same time. So we use the word or. In interval notation, we would say go from negative infinity to negative 2. And then in interval notation, there's a symbol for or, a big U for union. And then we start at 2 again and go on forever. So for the last 8 minutes, I'd like you to try working on 3, 7, and 9.